Here we guys go today. Quick thing, a couple things about this Rubik's Cube. This is not going to be the subject of today, but it is a cool little Rubik's Cube. Pretty cool. Anyway, not about 1x3. We're going to look at some 2x2 algorithms that, if you know how to solve a 2x2, they are very cool. They allow you to solve these things pretty fast. So if you know all your cases for 2x2, then solving the 3x3 in this way will be very, very quick. And it's not like the fastest way to solve it, but it is pretty interesting. If you've ever seen anybody do corners first method, I guess that's what it's called. I've seen a lot of people use different algorithms online. I don't think I've ever seen somebody do it exactly the way I do it. However, I picked up my technique by watching a bunch of different people and picking what I thought made sense intuitively and combining it into the method that I use today. So anyway, if I was to look at something like a 2x2, I would look for, like, I don't know, two sides put together, or these two sides put together, or maybe these two sides put together. Anything, it's probably not mixed up enough, but if whatever I had, I would try and put something together. So let's go for orange. So I got orange solved, and it just happened to be like that. What I like to do on the 3x3 is I don't like these edges to be mixed single bars all the way across. I do this to mix it to where I have opposites on either side. And it's a simple algorithm that I use a lot for solving and dealing with corners. And it's pretty cool. So after I solve the top, I'll look for a case, say like this. I recognize that this case where you have one on the side, two diagonally, and the other on the side, if you put this to the left of you, I know you're looking at me, so it looks weird. If I do a soon algorithm 3 times, the first time we'll set up the bar or headlights on either side, and then you do it 2 more times without changing the cube, with one hiccup because you're essentially going against yourself, one move, but it's just easy for the fingers to recognize and feel. You end up doing it just like this 3 times. And it solves it. Now you look for bar, or on a 3x3 to be headlights. I don't like the other color to be on the right because that makes a left-handed algorithm, but it's quick because there's also one on the other side. It puts it on the left, I hold it, and I do that same algorithm that mixed up the other side, that made these opposites. And why I saved those as opposites is because when you have the headlights on the other side and you've saved them as opposites, then you do this one last time and it solves the 2x2, and it would solve all the corners on a 3x3. Solved. Alright, so that aside, that is one of the ways of doing that. Of course, there's different cases and different algorithms for different situations, but that is the gist. That's what I like to do all the time. I set it up that way. It makes it consistent. Maybe not the fastest, but it's pretty fast, and it's also consistent. Now, the other thing is on 3x3s. So there's a couple of algorithms, obviously, with 2x2. There's the soon, which is one of the algorithms that I use a lot, extensively. There's the second one that jumbles up corners. And let me see. Let me solve this right quick. Da, 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 da. Okay. We're going to look at, let's see. Besides the Soon algorithm, there's also an algorithm that I use for mixing the edges. And then there's also an algorithm for, I guess it's inserting edge pieces, because I'm going to be dealing with edge pieces after the corners are solved. So, say if I had an edge piece right here and I wanted to insert it right here, I put it opposite, which it is, drop it down, move it over, move it to the other side, put it over, drop it back in, and it puts it in there. The only other algorithm that is used is one of two, and that is the one that invert flips all 4 on the top, or invert flips only 2 on the top. So the one that only flips 2 is done like this. And inverts 2. The other one inverts 4. And then it fixes them. And all of those algorithms together is how I use intuitively to put this thing together. So if I mix it, and we'll just mix 2 of them. That way there's different cases that arise. It's kind of mixed. So, 2x2, we look 2 together, bring the third one up there, get this one, throw it up there. Notice that there's a bar, split the bar, use the algorithm. Puts it together, mixes them, opposites, throw it at the bottom. Do a Soon case, put this at the left because it's diagonal like it was on the other one. 3 times. Done. Headlights. The left side for the right. Same algorithm. Solves it. Alright, we're going to do that, but on the 3x3. So I notice I have 2 up here, the other one's right here, and the other one's right there. So I'm going to put this right here, put this right here, and put this right here, which puts all 4 up there. Now I'm going to notice there's headlights. I'm going to keep it opposite of me, do that algorithm that I used for the 2x2. And now they're opposites all the way around. I'm going to spin this to the other side, and I'm going to work on red. Red's on the bottom. There's a piece on either side. So this is going to take 1 Soon. Solved. I'm going to throw, look for some headlights. There's white headlights right here. Bar and diagonal with green. Then I'm going to do that same algorithm that I like to use a lot. And it solves it. And then I just throw in the centers. And then you have all the edge corner pieces and all the centers in the right place. From now on, you're just moving edge pieces. And look, I have yellow, red is in there. So I'm going to work on the red side because it's the fastest. So moving this piece, which is green, red, up to here, where the green and the red is. So I'm going to bring it forward, bring it to the side, bring it to the back, insert it, bring it up. And that's what I do for all of the edges. going to look for another red one. There's red, blue right here. So I need to move it to the opposite side. I'm going to put it over here. From here to here. So I'm going to drop it down, insert it, bring it up. Now, the last one, I'm going to spin it in there, and it's going to be backwards, but I have an algorithm that flips backwards. So I'm going to move this up to put this, which is a junk one that I don't care about, and I'm just going to invert them both. And then bring it back down. And that solves red. I'm going to move to orange now. There's one already in place. Orange, white is right here. It's orange. So I'm going to put it right here. Insert it right there. Orange, green is right there. I'm going to put it over here. Then orange, blue is right here. I'm going to put it in there. And now the next part is to align the centers. So I put the centers here. There's one edge that's already correctly in place. In fact, there's two of them. And in which case, when two happens, it actually speeds it up because you move the two inverted ones next to each other, and you can flip them both. And then spin the side down. And then you're done. If we look at the next case, let's go for orange, because why not? You got two down here. So I'm going to move this down here, move this up. And I've now solved orange. And it's all almost opposite. I just need to split this green up. That algorithm that I like to use. And just for kicks, I'm going to throw the orange center up there. Now work on red. It's a headlight right here and a bar up top. So I'm going to hold the bar to the right hand side of me. Headlights to the side. I'm going to do the soon case, which is going to drop these headlights right here. They're now right here. Now from there, I'm going to keep them on the left side. Do it one more time. Single piece right here. Left side. Solved. Now I'm going to look for a bar. Here is green. And then the diagonal case again. I've set it up for myself the exact same as before, but with a different side. And now it's solved. I just need to move the green center and the red center. So now all the centers are places. It makes it look like an X all the way across the thing. That's what I like to see. And all the green are in the right place. Let's see. This one's in the right place. Green and white. So if I invert that, I now have it right there. I'm going to take the green yellow, which is right here, and I'm going to insert it right here. So do my insert algorithm, throw it in there. I'm going to do green, red into the red side. So I'm going to move the red over and throw it in there. And then on my last screen is green, orange. I'm going to spin this up into here. It's inverted, but I can just mix another one. And now the green side's done. I'm going to go for the blue. Nothing in the blue is in the right place. So I'm going to look for blue-red that's down here. I'm going to spin red to the opposite side. I'm going to insert from right here into right here. It's now in there. Now I'm going to look for another blue. I have blue, yellow, because it pulled the other one out. Yellow's right here. Blue, yellow's right there. I'm going to move it into there. Blue, white. I'm going to insert it right here. It's going to pull blue, orange out. Blue, orange is the last one. I'm going to insert it. Now I look for a completed edge. There's red and yellow. And I notice that there's three mixed up ones, which means that I'm going to need to flip it, spin it towards me, spin it back, and then flip it. The cube is solved. So those are some different scenarios for the corners first method.